Hi, I'm going to show you how to use the seaborn Python package as part of day 3 of the course called Using Python in an HPC Environment as taught by these centers. I will do so for the Pelle HPC cluster, the Pelle HPC cluster by UpMax. This is the seaborn logo, and in this session we will practice using the documentation of your favorite HPC cluster, Pelle in this case. I will tell you why seaborn is important, and we have created a plot with it. This is the most important part because the course is about using Python in HPC environment, and that's unique to this session. I'm going to show you how to use seaborn in an HPC environment, but I'm not going to do anything smart with seaborn. You can find out how seaborn works exactly in any environment. The focus of this session is to get it running on HPC. There is an exercise about this, but I will skip discussing this. Good. What is seaborn? Seaborn allows you to create figures. Here we have some kind of a bit of Python code, and here we have the figure it creates. That's basically it. Seaborn allows you to create figures. Why does this plot look identical to the matplotlib plot? So there's an earlier session in this course where I show how to create a plot using matplotlib. Indeed, it's exactly the same thing because seaborn uses matplotlib. Seaborn is one of the most popular Python plotting libraries. It can be used to create publication-ready figures, and there's a plot gallery, and I'll just take a quick glimpse of it, which plot types are present. So take a look at the example gallery here, and here we see all kind of different plots, different types, different complexity, going from very simple to very pretty complex plots, like this one for example. And if you click on them, you get also to see the code that created them. All right, that's a useful overview, not part of this session. Let's take a look at the exercises. So let's take a look. Exercise 1 is to run a minimal seaborn program. Exercise 2 is a minimal plot. And then we have optional exercises that I won't go into about displaying a pandas table or making a plot pretty. I will be only showing you the HPC part of this session. So exercise 1, a minimal seaborn program. And we start from using the documentation of the HPC cluster you work on. So let's move this part at the left, and we're going to use the Pelle documentation. So I'm going to search for Pelle HPC cluster documentation UpMax to find this, and there we already have it. Pelle UpMax HPC cluster documentation. This is correct. This is how Pelle's documentation page may look like. There's plenty of other things here under the search box, but this is it should be UpMax documentation. UpMax maintains Pelle. UpMax is the HPC center for Pelle, the HPC cluster. Good. In the documentation, find the software module to load the package. So what I'm going to search for the word seaborn. Well, it's a first hit as its own page. And I guess this is how you load seaborn. So we found it. I'll make this a bit bigger too. There. So this is very well documented here. This is what you need to do. Now in a terminal on your HPC cluster, load the software module to use seaborn. So I'm going to copy paste this text. You can click here, whatever you prefer. Now it's time to go to Pelle. So I have Pelle opened already. So you'll see that the login screen is correct. I'm on Pelle. I will move this also to the right side of the screen, so now it doesn't look as pretty anymore. And I use Ctrl-Shift-V to paste this text. I will press enter, and now I have seaborn loaded. Next, on your HPC cluster, create a script called seaborn exercise _1 Python with the following code. Run the script. Well, to create the script, we're going to use nano seaborn 1 exercise 1. Let's see if I can copy paste this from the answer. Alright, this is running the script, but how to create the script, I'll show this. You use nano. You can use other editors, and if you type nano and then the file name, Ctrl Shift V, it will create a file with this name. So press enter now. Now I need to copy paste this text, so I'm going to click here on copy. I go back to Pelle, Ctrl Shift V to paste it. And this means if I now exit, I've created a file with this name, seaborn exercise1.python, and with this code. I can also press Ctrl O. I do it Ctrl O to save. I press enter. This is the correct answer. And I press Ctrl X to exit. And now I've created this file. Good. Next, run the script. So this is Python and then the name of the script. You saw that it auto-completed. If you use tab, it will auto-complete. I press enter. Let's take a look if it worked. So when I do module load seaborn, I assume it loads also a Python module. If not, we need to load a Python module. Let's take a look how this looks like. Just taking a look at the script, it will probably only print a version number. So it will only print some numbers. And that's it. And while we're waiting for this, what do you see? You'll see there will be numbers being shown. It's still thinking about. There we have it. Apparently we've used seaborn version 0.13.2. That is correct. This is exactly the name of the module we've loaded. Next question. Even though the code shows nothing directly useful, why is this a useful exercise anyways? Well, because now we've proven that we can actually load seaborn. We don't do anything fancy. We only show the version of it, but it means it exists. And we can actually ask the version of it and print that. Like, so this is the minimal, like this program is very useful because it's the minimum test, the lowest test that you can do to seaborn, like the easiest test. If you can't get this to run, seaborn won't run. Alright, next exercise. We're going to create a plot. Alright, let's do that. On your HPC cluster, create a script called to the nub with the following content. Alright, so I'm going to create a new script using nano, replaces by 2. There, I'm going to copy paste the code again. Here's copy. Back to nano, Ctrl Shift V to paste. You'll see that there's this little less than sign here because it doesn't fit on one line, and this is how nano shows this. But it's there. I'm going to save with Ctrl O. I press enter because this is a good file name. I press Ctrl X to exit, and now I have it. Let's run the script. Well, I'm going to use Python exercise 2. There. And now it's running the script. Right, this is already done. Check that the figure is created. So let's take a look. The figure. This is probably the figure. This is the figure being created, and we need to find on Pelle if it's there. So one thing to do is you do ls to list all the files, and indeed we see it is present here. So now we can be reasonably sure it works. Sometimes sometimes it's possible to also directly see it, and I know on Pelle, if you log in using X forwarding, whatever that is, you can see it like this with EOG, the eye of GNOME. Now it will display the figure 2 directly from Pelle. This is if you log in with X forwarding enabled. You need to figure out how to do this, but this is a way to do it. Good, so we've checked how the figure is created. And that means that now we are going to reach the optional exercises. I'm not going to go into those. Instead, I'm going to scroll up and I'm going to end this session by I've created now that we've now learned how to get seaborn working on the Pelle HPC cluster as part of this course. With that, I wish you a very good day. Bye!